Right, welcome back. Today we're going to sort out radioactive decay. Okay, we're going to look at the three types of radioactive decay. We're going to look at alpha particles, which look like this. This is a symbol for an alpha particle. It has 2 protons and 2 neutrons. So the mass number is the atomic number plus the neutrons. So that gives us 4 big particles there, 2 protons. It's like a helium nucleus with no electrons. We're also going to look at beta particles, which is a high energy electron that is emitted when a neutron turns into a proton and an electron. More on that in a minute. We're also going to look at gamma radiation, which you've learned already as a part of the EM spectrum. So it's high energy, high frequency radiation there. So, first of all, we need to, at GCSE level and GCSE AQA physics, all we need to sort out is the numbers. We don't need to know the periodic table off by heart. So let's take an example of alpha emission. So if we start with uranium-238, which has an atomic number of 92, it's an isotope of uranium. It's not happy, it's got too many neutrons and wants to emit some energy. So it does this by emitting an alpha particle. Oh, wrong number there. So it's given off an alpha particle. So we've taken away 2 protons and 2 neutrons. So the mass number is protons plus neutrons. So all we need to do in the case of any alpha decay is we take 2 off the atomic number, which changes this to 90, and we take 4 off the mass number, which changes this to 2, 3, 4. Now if you look at the periodic table, element 90 is thorium. Now you don't need to know this for GCSE, you just need to be able to do the numbers. So take 4 from the top, take 2 from the bottom, and we end up with these numbers for alpha decay. Now let's say this was all of a sudden still not happy, it's still got too many neutrons, it's unstable, and it's going to emit a beta particle. Now, the top number is dead simple, it remains the same, so it's 2, 3, 4. The bottom number, we need to know what number plus minus 1 gives us this number. So we've had a neutron that's turned into a proton and left over a beta particle which has been emitted. So this number actually goes up by 1 to 91, which gives us the element Pa. Memory is not helping me here, I can't remember what element that is. Okay, so when that is given off, when a beta particle is given off, the mass number goes up by 1 and the atomic number stays the same. Now, what's going to happen now in this decay series is a gamma ray is going to be given off. So it's still unstable, it needs to give off a little bit of energy, and it does so in a gamma ray. Now a gamma ray is just electromagnetic radiation, it's a type of high frequency light, it has no mass, therefore no protons, no neutrons, so it remains exactly the same. It stays exactly the same and remains like so. Okay, so if an alpha particle, a helium nucleus, is given off, you take 4 off the mass number and you take 2 off the atomic number. If a beta particle is given off, that happens when a neutron decays into a proton and an electron, and the electron here is basically this beta particle. Then the atomic number, because we've got an extra proton here, the atomic number goes up by 1, as you can see between the 90 and the 91. Mass number remains the same because the mass number is protons plus neutrons, and all we've done is exchange one for another. And then gamma, when gamma radiation is given off, the mass number and the atomic number remain the same.